Hello people, and welcome to your second chemistry tutorial on hydrocarbons. So guys, we just finished with alkyl groups in the first tutorial, and now we're gonna move on to alcohols. So again, I missed my color, so I'm gonna use a different color now. uh, Alright, so alcohols. Alright guys, so you might have noticed this notation a lot of times. Now guys, what this basically means is that this R is nothing but the alkyl group, as I just discussed last tutorial. This is your alkyl group, and this right here, let's change colors. Which one? I think green. This right here is the OH, which is nothing but the functional group. So guys, you need to remember these two alkyl and functional groups and what they basically indicate in a compound, because the functional group is always associated with the chemical I repeat, chemical properties, and the alkyl group is always associated with the physical properties. So guys, alkyl for physical, and functional you have chemical properties. Oh, where did that vanish? Okay, I'm sorry, I'm gonna rewrite that. So this denotes the chemical properties of the compound. So guys, I'm just gonna go through the naming and the drawing the structure part bit. I also missed out a certain key aspect of the drawing bit of structures in the last tutorial, which is isomers. So guys, I intentionally did not draw isomers of pentane and pentene and butane and all of them. However, they do exist. So why? Because I'm just gonna draw them right now, and I'm really tired. It's 3:28 a.m. and anyway, still taking my caffeine input and staying awake, so that all of this finally donates to a good cause. Alright guys, let's help you with your alcohols now. Now we had to draw the structures, right? Yeah. So the first one, which is CH3OH. So you gotta remember this, very, very important. This is also known as methyl alcohol, as the name suggests, because of the root word, and alcohol because of the suffix. So you got methyl alcohol. Often a question here is asked as to why is methyl alcohol known as spurious alcohol or poisonous alcohol. Please check this question out, because this is the most important question by far in the alcohols part. So you have to learn this out, that this is also known as spurious or poisonous alcohol, because this is actually poisonous, and if consumed by a man um, or any being, um, it could well be fatal. So spurious or poisonous alcohol, and the one that you actually not use, sorry, the one that adults usually drink is the other one, which is C2H5OH. It's ethyl alcohol, and it's also known as ethanol, although I'm just going to write ethyl alcohol, or ethanol is the IUPAC name, and IUPAC is nothing but International Union of Pure and Applied Chemistry. So guys, yes, so this is your ethyl alcohol, and this is your first one, which is CH3OH. Now if you've not noticed till now, then CH3OH and C2H5OH, they have general formula CN what's wrong with my pronunciation? CnH2n plus 1, basically the same one as an alkyl group. So it's just the same thing, except that you have an OH attached in this case. So guys, that's pretty much it. For propanol, I'm just gonna be drawing the at least one isomer. Please understand the basic idea. We do not have time, we cannot keep on drawing all the isomers. Please understand guys. So thank you. And no, I'm not finished yet. I know I'm not finished yet. So let's just draw propanol, guys. Propanol would be So the propanol, the prop, or the meth, or the eth, or the whatever, the first bit actually indicates how many um, C's are there, or how many H's, or how many what number is attached to the first H. So for instance, if you have or the C. So for instance, if you have propanol, guys, then you must understand that there's a 3 coming somewhere. So 3 will come at the C. So it'll be C3 H 2n plus 1, which is 2 6. So C3 H7 OH. Now how am I gonna draw this? I'm just gonna draw this simply this way. No double bonds, no nothing, no nowhere. So this is how you draw it. H H H, and I'm not going to draw the entire H is, so I'm just going to draw these lines 1 2 3 4 5 6 7. So got C3H7OH. Now guys, this could well be this is actually propanol 1. Now if I have to draw propanol 2, then there will be a change in the structure, in the geometry. So the only change will be that the O, guys, will shift to this place. So it'll just be this way: C C C H H H. Here, right here, you're just gonna draw an OH here, and rest otherwise you're just gonna draw an H. So 1 2 3 4 5 6 7 H's, 3 C's, and 1 OH, which denotes the alcohol. So guys, there's a big difference between OH and over here and OH over here. This is propanol 2, and this is always numbered from the left or the right, as you've already I'm pretty sure all of you already know this. You give the least number to the alkyl group, which is OH in this case. So guys, um, that's what we have right now. Oh yeah, and I'm sorry when I said you give the least preference, you give least number to the alkyl group. It's not actually the alkyl group, it's the functional group. I'm sorry, I just noticed. Guys, that's pretty much about the numbering and the isomerism part of propanol 1 and propanol 2. I think I'm just going to be moving on to now, which one do we do first, aldehydes, ketones, or carboxylic acids? Let's just wrap all of this up right now. We'll start with aldehydes. So I'm Zing right now. I'm control Zing. Life is tough. So guys, aldehydes are now what we're doing, and commonly represented as RCHO. Where does my toolbox disappear? So RCHO, guys. So RCHO, the R here is the alkyl group again. Same thing again and again, just to get it inside your brain. CHO here, functional group, FG, functional group, and again, get this into your head. This is the physical property determinant, and this determines the chemical properties of the compound. So guys, that's what aldehydes are, and that's what the basics are of in aldehydes, I'm sorry. And now I think I'll be utilizing some space right here, and doing a little bit of naming and organizing the structures of aldehydes. So guys, the first one is HCHO, and this is what we take into consideration first. So HCHO is also known as I want to change my color, blue. Okay, so HCHO, guys, very easy. This is the first one, don't get scared. It's also known as formaldehyde. Alright, it's also known as formaldehyde, and although its name is methanol. So guys, another thing to remember here is that their suffix is -al. Like alcohols, they had OL, like all. Aldehydes have an -ul in the end, so you call it aldehyde. It's methanol formaldehyde is the same name for methanol. Alright guys, so how do you draw the structure? The structure goes something like this. It's HC, you have a double bond here, and the double bond, there is an O here. So this is the first bit. Then I'm just going to draw one more, since I'm guessing you've already done this, guys. Second one is CH3CHO. Alright, and just the third one, I'm just going to do this right now. The third one would be C2H5, if I'm not wrong. Yeah, it should be this one. CH2H5CHO. CH3CHO. What is this? I think, yeah, this is ethanol. Oh, I haven't forgotten all of this. It's good. It's good to know. So ethanol, guys, ethanol. See, it's so easy. It's so conceptual. You guys can understand this. This is very basic stuff. I've seen people who don't get easy chapters get this chapter and score better than even the best of kids in the batch that we had. So, guys, ethanol is CH3CHO, and it's structure. Once you get the naming right, the structure is pretty easy. Just arrange the C's and the H's and the O's. So guys, ethanol will have a structure like this. Well, you have just one C. However, there's another C here in the CHO, so you have another C here, and then you have this O here. I'm sorry, I ran out of space. Hodgepodge, but I'm really tired, so and I'm lazy also. So this is your OH, that's CHO, and CH3, right? So there will be three C's over here. So that's the easy part, and that's the only part you need to know in aldehydes. Let's move on to something um, I don't know if it's more interesting, but let's just say that it's very interesting. Let's progress, um, you know with an optimistic approach. So guys, now what we're talking about is ketones. Very easy, guys. Interesting. So kya? Very easy. It's only one of the compounds that you have to know, and that is wait, let me put in the heading first. I like this blue. So it's ketones. And do I have time left? Yes, I do. So guys, yeah, let's get back again. They have an RCOR here. Now you gotta pay attention here. Changing colors to something, maybe this would be fine. So RCOR here, guys, is this is the R here, this is again another R here. Both these R's are alkyl groups, determining the physical properties. And this CO right here is nothing but the functional group Fg, determining the chemical properties. I'm tired of writing. Okay, so the only compound in discussion for you guys is known as propanol. It's CH3CO. So guys, it's COC right here. It will always be CO. Like in aldehydes you had CHO, and in alcohols you had OH. So this would just be CH3COCH3. So what would be the structure like, guys? Let's guess. In fact, guess what? You guys are so intelligent, I'm pretty sure you figured it out already. So there you go, CH3, fine. So you got three H's. That's how you progress. Alright, now I want another CO. So in case you're doing this for the first time again, C, the O will be attached this way. Okay, just remember this. This is something you have to learn. Although you can understand that it uses two bonded pairs, so it'll only use two others right here, and you won't put an H right here because C has tetravalency, and which means it has four electrons in its outermost shell, so it needs another 4 to complete its octet. So CH3, that's what you have then. That's known as propanol. Although according to its configuration it's known as propanol 2. So if you can remember that, good. Otherwise I won't force you. So guys, we're done with ketones as well. I think now we're only left with carboxylic acids, and I don't really know whether ethers or esters are in your syllabus. However, I will just be rushing through with that too. And guys, I'm thinking about the equations. I don't really think there's anything I can do much with you guys, since I just got to know, I talked to the teachers at our school, and they said that the syllabus is very clear and the equations have been marked out. So guys, just go through the equations, and if at all you have any doubts, please approach your teachers, any teacher of the respective subject. You've got wonderful teachers at your school, and it was a great adventure, and um, great 2 years being a part of TSRS. So guys, let's now move on to what is it? I think we'll move on to carboxylic acids now. Again, very easy. All of it, it's so easy. However, just one trick while naming and drawing is easy part once you get the names. Also guys, I remember losing marks, although that's me, that's not you guys, where you had to draw the structural formula, but I just gave the molecular formula, and there was a 10-mark question and all 10 were correct. And unfortunately for me, I lost those 10 marks. So yes, I have fallen into my 60s once in chemistry, but that was only once. I think in the final exams, and then at pre-boards again I picked up. So guys, let these mistakes not happen to you, not occur in your paper. Just be cool. I know you're doing this for the first time in class 10, in fact in your life, so just take it easy, because you never know what's in store for you. So carboxylic acids. Alrighty. So guys, now I'm just gonna be talking about their general formula first. So talking about the general formula, guys, it's R C O O H. Where is my color? So yeah, guys, in this RCOOH, your R is the alkyl group. I'm sure you guys can identify these by now. So this is your alkyl group determining the physical properties, and the COOH is constant again, and that's your FG for functional group. So guys, this is how you denote it. It's RCOO. Yeah, OO. So the OO is just like there's an O going up, flying in the air, and the O going side by side. So guys, this is about the naming part. I mean the general formula. Now let's just move on to how you name certain carboxylic acids and how you draw them. So the first one, let's consider HCOOH. Now you gotta learn the first one in the member series. Just learn up all the first um, particular homologue series members, because sometimes in the fill in the blanks and true and false you ask these kind of stupid questions, but still, I mean the paper setters want to test you on this, so please just remember it. If you do get a chance to, then please. So HCOOH, what do you call it? It's just methanoic acid, alright? And since it's the first method, we call it the methanoic acid or methanoic acid. And like just like this, its general formula, the way of representing it is this way: HCOOH. And this is how you draw the structure. Methanoic acid is its IUPAC name. Another one that I'm going to draw is, I think, let's take up propanoic acid, right? So when you take up propanoic acid, you have to remember that there are again 3 C's in all. So if there are 3 C's, then you have to consider this C meaning this C of the functional group. So you do take into consideration this. And this is the tricky part. So you have 3 C's over here, and all rest of it is really easy, where you have a double O here, not the 007, but just the double O, and here, right here, you have I think another O and an H. So guys, that's about it in carboxylic acids too. I'm just short of time, so I think I will be making another tutorial, just one more, not getting much into equations, just giving you a boost to open your book and actually do it. But just finishing ethers and esters in the next tutorial. I know I'm really informal, and sorry about this right now, but seriously, there's no way you can imagine what state me and Karan are right now. So See you guys on the other side. Thank you for watching, guys, and keep smiling.